In this video, I'm talking about in a three-phase circuit. If I give you a phase value or line value, either in star or delta, how to find the other values. Like if I give you phase current, how to find line current. If I give you phase voltage, how to find line voltage, and vice versa. Now, in this, first example, he gave you, it's a Y connection. It could be a load or source. It doesn't matter for us at this point. He gave you VBN at equal to 120 at an angle of minus 170. He's asking find VAB. Okay, remember, whenever you see BN, N is nothing but neutral, so this is a phase voltage. AB between two phases, that's a line voltage. Okay, so he gave you phase value, he's asking about line value. Okay, he gave you Y connection. Whenever you see Y connection, immediately you need to remember, or you need to get into your mind these important things. IL equal to IPH, so line current equal to phase current, and line voltage equal to square root 3 times phase voltage, and power equal to root 3 VL IL cos theta, or you can say 3 times VPH IPH cos theta, where cos theta is the power factor. Phase angle, theta is angle between phase voltage and line phase voltage and phase current. Okay, another important point you need to remember, in Y connection, line voltage leads. This is leads. Okay, line voltage leads phase voltage by 30 degrees. That's another important point you need to remember. Okay, so as long as you remember these 3 points, 1, 2 and 3, you should be able to find VAB. Okay, so since he gave you VBN, let me write down VAN, VBN, VCN. Okay, so he gave you VBN, which is 120 at an angle of minus 170 degrees. Okay, so VCN must be 120. I'm assuming it's symmetrical, so all 3 phases are going to be same in symmetrical. So 120 at an angle of minus 170 minus 120. Okay, and VAN equal to 120 at an angle of minus 170 plus 120, because if you remember in my previous videos, I always give you VAN equal to V at an angle of 0, some magnitude, VBN equal to V at an angle of minus 120, VCN equal to V at an angle of minus 240. That's how I did it. So you may need to remember this one too. So here I gave you VBN value. So VBN 120 at an angle of minus 170. So to get VAN, all I need to do is add 120 degrees. That's what I did there. And to get VCN, just subtract minus 120. Okay, so VAN, I found the VAN, which is VAN equal to 120 at an angle of minus 50 degrees. Now, but the question is, he's asking about VAB. VAB equal to square root 3 times VAN. So VAB must be square root 3 times 120. At the same time, this is the Y connection. In Y connection, the line voltage leads the phase voltage by 30 degrees. So minus 30, minus 50 degrees plus 30 degrees. Okay, you're finding line value. He's saying that line voltage leads the phase voltage by 30 degrees. Since it is leading, I have to add that, and that's a plus. Okay, so it is square root 3 times 120 is nothing but 208 at an angle of minus 20 degrees. This is how we'll find the line voltage from the given phase voltage. Another way of solving this is by using a vector diagram. So for any Y connection, vector diagram must be same. So let me create some empty space here. Okay, so here is the x-axis and y-axis. Okay, so he gave you VBN 120 at an angle of minus 170. So that's 0, minus 90, minus 180 degrees. Okay, minus 270 degrees. Now VBN equal to 120 at an angle of minus 170. Minus 70 is going to be somewhere there. This is VBN. This value is minus 170 degrees. Now where will be the VAN? VAN must be in front of it, and the angle must be between, so this angle must be 120 degrees. So this is VAN. This angle is, I'm saying, 120 degrees. Okay, VAN. What is this angle then? Okay, so if this angle is 170, this must be 10 degrees. So that's 10, 120, so 130. So this angle must be minus 50 degrees. Okay, now but the question is asking about VAB. So this is VBN. If I draw it in negative direction, that's negative VBN. VAB is going to be vector sum of these two. It's going to be somewhere here in the middle. Okay, so that's VAB. Or another way of saying this is, in Y connection, line voltage leads phase voltage by 30 degrees. So VAB is leading 30 degrees here. Okay, so what is this angle? This must be, that must be minus 20. So here this angle must be minus 20 degrees. So that's another way of finding that. VAB equal to 208 at an angle of minus 20. So sum of these two must be square root 3 times VAN. So it's a vector sum, it's not arithmetic sum. So that's the reason it's square root 3 times. Okay, now if, say for example, if this is a delta connection, instead of Y, if it is a delta connection, in delta immediately you need to know phase voltage equal to line value. So if the given value is VBN, so VBN equal to 120 at an angle of minus 170, what will be VAN? VAN equal to 120 at an angle of minus 170 plus 120. So VAN comes first, then VBN, then VCN. Okay, so in delta, phase and line values are same, so VAN must be VAB, which is 120 at an angle of minus 50 degrees. Here is the next example. In a delta connection, ICA equal to 30 at an angle of minus 260 degrees. Find IAA. So current in line A. So it's a delta connection. He didn't mention whether it's a load or source. It doesn't matter. Let me take that as a load, because I'm taking that as a load because he's talking about ICA. I will tell you in a second. So this is A, B and C. When it comes to the load, usually we represent with the small letters. Okay, A, B, C. Okay, so I should have represented this as a small letter. Let me represent this as a small letter ICA. Okay, now so this is IAB, this is IBC, that is ICA. Okay, if it is source, current is going to flow in the opposite direction. Okay, when it comes to the source, so here is A, so here AA. So this is what he's talking about. He's asking us to find the line current in line A. He gave you the phase current. Okay, so when it comes to delta, the important points you need to remember: IL equal to square root 3 times IPH, VL equal to VPH, P equal to 3 times VPH IPH cos theta, or square root 3 times VL IL cos theta. You need to remember these things when it comes to the delta connection load. Another important point you need to remember is, in delta, line current lags phase current by 30 degrees. So in delta, line current lags phase current by 30 degrees. So in this case, he gave us the ICA. he's asking about the line current. So can we find IAB from this? So ICA equal to 30 at an angle of minus 260. Now IBC equal to 30 at an angle of minus 260 plus 120. Okay, we are coming back. And IAB equal to 30 at an angle of minus 260 plus 240. Okay, so basically I end up with IAB equal to 30 at an angle of minus 20 degrees. Once I have IAB, here he's asking about IAA. Okay, the line current IAA equal to, it must be square root 3 times IAB. Okay, at the same time in delta, line current lags phase current by 30 degrees. So IAB is the phase current. So phase current is 30 at an angle of minus 20. So this is IAB. So where will be the IAA? IAA must be, the angle between these two is 30 degrees, and IAA must be lagging. So lagging is down there. Okay, so IAA must be square root 3 times IAB at an angle of whatever given angle minus 30 degrees. Okay, so IAA must be square root 3 times 30 at an angle of minus 20 minus 30. So it will be square root 3 times 30 at an angle of minus 50 degrees. That's the final answer, IAB. Okay, now say for example, if this is a star connection instead of delta. If it is star connection, we just saw the line currents and phase currents are equal. Okay, so once we know ICA, if it is Y connection, if it is Y connection, IC equal 30 at an angle of minus 260 degrees, we know that I line equal to I phase in Y. Okay, in Y connection, line currents and phase currents are same. So that is a phase current as well as line current. So if I know ICA, can I find IBC and IAB? Okay, IBC equal to 30 at an angle of minus 260 plus 120. IAB, okay, IAB equal to, this is my phase current, sorry, yeah, that's my phase current in this case, equal to line current, which is IAA. That's the line current, 30 at an angle of minus 260 plus 240. Okay, so 30 at an angle of minus 20 degrees. That's my line current. I will stop this video here. I will solve a couple of more examples in the next video. Thank you.